So first off, what are normal maps? This may seem like kind of an obvious question, but in my experience there are a lot of artists who simply view them as bump maps, and that's not really the case. When you're talking about normal maps made from baking high poly geometry onto a low poly model, what you're really talking about is a system to replace the low poly model's normals with those of the normals from the high poly. That means that they aren't just a system to add high frequency detail, but can actually improve the shading quality of the low poly model. So there are a couple different kinds of normal maps, and for our purposes we're just going to be talking about object space normal maps and tangent space normal maps. If you look at the screen, there's two geospheres. On the left, it's an object space normal map being used, and on the right, it's a tangent space normal map. And you can see these both shade the same. But if I switch the normal maps into the diffuse channel, you can start to see what's going on. So on the left, you can see that each triangle has its own color, and that's because each color in this object space normal map literally corresponds to a different angle in the world. This is a really simple system, and it works by completely overriding the low poly model's normals. And on the right we have this tangent space normal map, and as you can see the big difference is that the object is a uniform color. And that's because a tangent space normal map works by defining the normals relative to the surface of the mesh, not to the world. So instead of having separate colors to tell it to point in every other direction, it just uses the orientation of the low poly model and tells it to point outwards. Another way to think about this is that with a tangent space normal map, your normal map is compensating for what the low poly normals are doing to create the appearance of the high poly model's normals. So generally video game engines use tangent space normal maps and not object space normal maps. And there's a couple of reasons for that. Some of them are technical and some of them just relate to how easy it is to work on or edit tangent space versus object space normal maps. However, the thing that makes normal mapping a lot more difficult is that tangent space can be set up in an unlimited number of ways. So the coordinate system that's used to define what is out and what is up and left and right, and how the orientation of the normals are affected by specific colors in the tangent space map, it's essentially unlimitedly variable. There's a whole bunch of different approaches to take, and on top of that there's a whole bunch of numerical variations that can be made in order to create an essentially unlimited number of options. What this means for artists is that the tool you're using to bake your normal maps needs to be specifically targeting the game engine you're going to be using to display the normal maps. So if the system to create the tangent space for the baking tool doesn't match the system that's used to render the tangent space for the game engine, you're going to get shading errors and unpredictable results. So here's an example of a low poly model where the tangent basis that these normals were baked with perfectly matches the tangent basis that's being used to display the normals in the viewport. So if I switch the material over to a simple blend material, you can see that on this low poly model there's all these little shading artifacts. And that means that in this case the job of our normal map is in part to compensate for what the low poly model is doing. So if we apply this normal map again, I can switch the tangent basis over to a different normal map that isn't correctly synced. So now you can see this is what happens when you attempt to bake a complicated smooth model with a tangent basis that doesn't match between the baking and rendering software. So to get a better idea of what's actually happening here, if we bring in the normal map and zoom in, you can see that there's all these gradients on the normal map. And those gradients are areas where the normal map needs to be correctly compensating for the smoothing of the low poly model. So unlike the normal map for our geosphere where everything was just sort of flat blue, in this case there's a pretty complicated calculation that's made in order to create these exact pixel colors and these gradients that will correctly flatten out the shading from our model. I like to think of these kinds of gradients as being tension in the normal map, and the more intense they are and the tighter they are, the harder the normal map is working in order to compensate for the low poly model's normals. In the next video I'm going to be talking about how to control shading behavior in such a way that you can reduce the number of these gradients in your normal map, which will allow your normals to be a little more flexible and work between different game engines where things aren't necessarily synced up correctly.